Okay. Yes. Now in this video class we are moving on to the standard values and we'll be covering the color coding. Now the standard resistance values are calculated using the formula R is equal to D into 10 raised to I by N. The unit is ohm, where D is a decade multiplier. It can take the values 1, 10, 100, 1K, 10K, etc. And N is a tolerance series. By 1% is equal to 96, 2% is equal to 48, 5% is equal to 24, 10% means 12, where I ranges from 0 to N minus 1. If we got a value as, now we are going to see an example. If we got a value as 355 kilo ohm, to get the standard value, we need a table to be used. Let the tolerance be 1%. Check in the 1% table and find the nearest value to 355. Nearest value to 355, that is 35.7. So select it and multiply it by 10,000 to get 357 kilo ohm, which is the standard value to be used. This is a 1% table from which we got that value. Similarly, this is a table for the resistors with 20% tolerance and the resistors with 10% tolerance. Now we are moving on to the marking. There are three types of resistor markings. One is color coding, second is numerical value coding, and third is a 3-digit symbol coding. In that, first we are coming on to the numerical value coding. In the resistor, the 3-digit or the 4-digit resistance indicating number will be present. For example, over here we have the 4422 and 442. First one is a 4-digit and second one is a 3-digit. So if the number is 4422, it is 442 into 10 raised to 2 ohm. That is 44200 ohm. It is equal to 44.2 kilo ohm. If the number is of 3 digits, for example 442, it is 44 into 10 raised to 2 ohm. That is 4.4 kilo ohm. Now we are coming to the 3-digit symbol coding. We have a table for 3-digit symbol coding for all standard resistance values. From the table, we select the 3 digits for the resistance value needed. The tolerance is 1% and the resistor value is 12.1 ohm. Now the 12.1 ohm can be written as 121 into 10 raised to minus 1 ohm. From the table, for 1% tolerance, 121 corresponds to 0.9 and 10 raised to minus 1, because 12.1 can be written as 121 into 10 raised to minus 1. So 120, it corresponds to 120. So when we just say 121 ohm corresponds to 0.9, over here 121 corresponds to 0.9 and 10 raised to minus 1 corresponds to R. So the 3-digit code is 09R. For example, if the 2% tolerance and 1 ohm is equal to, that is 100 ohm is the value present in the table, minimum value present in the table. So we can write 1 ohm as 100 into 10 raised to minus 2. So for 100 we'll get as 0.1, and for 10 raised to minus 2 we get as S. Since we added zeros to get the value in table, we write as S01 from the table. And now we are coming to the color coding. Now the color coding, we have the resistor color code with 4-band resistor and a 5-band resistor. The 4-band resistor, we have first band, for the second band, third band. For the 4-band resistor, we have 3 bands indicate 3 bands. Out of that, the first 2 bands give the color, third band gives a multiplier, and the fourth one gives the tolerance. In the 5-band resistor, the first 3 gives the color band, third one gives the tolerance multiplier band, and the last one will be giving you the tolerance band. So the first one, that is indicates the first 4-band resistor indicates green color, which gets the first value as 5. Then comes the blue color, which gets the value as 6. Then comes the yellow color, which gets the value of the multiplier as 10. So the value directly comes as 560 kilo ohm with a tolerance of silver color, that is silver color tolerance is plus or minus 10%. So the value comes as 560 in kilo ohm with 10 plus or minus 10% tolerance. Similarly, for 5-band resistor, the first color is red, indicating the color from the red gives you value 2. Orange gives a value 3, and this violet gives a value 7 from the 3rd band. We have a black color giving the multiplier. Black color gives into 1 multiplier, and the tolerance is 1%. So the value comes as 237 ohm plus or minus 1% tolerance. And this is the same example shown with the values. Now comes to the variable resistors. These are some of the pictures giving the variable resistors. And we have the rheostats, what we call the wound resistors. The manufacturing, the nichrome wire wound on a ceramic core and covered with an insulating material. An adjustable tap rides along the exposed wire, which makes electrical contact with the wire. It is a 2-terminal device used in power supplies and low-frequency AC circuits. It's not suitable for high-frequency application. There is a picture giving the rheostat. Now the specifications are given below. The potentiometer, it's a figure, that is a picture of a potentiometer. We have what's happening inside. The connections are 3 connections: the slider, the curving track, control shaft is shown, sliding contact, and the rotation which is possible. This is a representation with wiper turns with the dial and the resistive material. Variable resistor consists of a track which provides a resistance part. The track is usually made of a mixture of ceramic and metal, or can be made of carbon. For applications of small resistances, the resistance track may just be a coil of wire. The track can be in both the rotary as well as straight versions. A track made in a straight path is called a slider. This is a sliding potentiometer and a rotatory potentiometer. Now, a wiper connected to a control shaft. Movement of wiper provides a continuous variation in resistance between the middle terminal and the outside terminal. Often used as voltage dividers to control a vary voltage across a circuit branch. Usually a shaft rotation of 270 degree moves the sliding contact along the full length of the potentiometer. Now here is a table giving the specifications. Now the features are low cost, long life, low noise, reliability, controlling volume in radio receivers and brightness of pictures in TVs, process control panels and service systems. Rheostat and potentiometer comparison. For low power applications, it's used for low power applications less than about 1 watt. Rheostat must be rated for higher power, more than about 1 watt. Potentiometers are often used to vary voltage, and rheostats are used to vary current. That is the main difference. Now comes to trimmers, also known as trim pot. To trim the circuit to the required operating condition by inserting a small screwdriver into a slot and turning 1 or more times. Available in single turn and multi-turn. The value of resistance is commonly adjusted with the help of a screwdriver. After these presets are just smaller versions of a variable resistor. These are the representations, diagrams of trimmer shown. This is trim pot symbols. The following IC symbols are used for trim pots and preset resistors. Although these are the official symbols for occasionally adjusted resistors, the standard symbols for a potentiometer or a rheostat are often used. Now these are the specifications that are regarding the range, resistance range, tolerance, power dissipation, and temperature coefficients of resistance. Now these are some of the symbols that we normally use. Now coming to the non-linear resistors, these are made from semiconductor materials. Non-linear property due to breakage of covalent bonds by the effects of temperature or applied voltage or light. So current is not linear to applied voltage. The 3 types are photoresistors, thermistors, and varistors. First come the photoresistors, that is LDR, light sensitive devices, most often used to indicate the presence or absence of light or to measure the light intensity. Now they are made from semiconductor materials, cadmium sulfate, cadmium selenide, lead sulfate. The higher the light intensity, smaller the resistance. The result is a device sensitive to different wavelengths of light. The resistance normally ranges from 100 ohm to 100 kilo ohm. Now this shows the graph relating light intensity and the resistance. Now it shows you the figure and the symbol. Now comes the thermistor. Thermistor, temperature sensitive resistor. The temperature sensors, temperature compensation, electric circuit happens here. Main applications are two categories based on material, metallic oxides or semiconductor varieties, and based on temperature coefficient PTC and NTC. Now based on the material, we have metallic oxides, whereby the temperature ranges 200 to 700 Kelvin, and manganese oxide, nickel oxide, cobalt oxide, copper oxide is being used here. The semiconductor, lower temperatures, germanium 100 Kelvin, silicon 250 Kelvin is being used. Now NTC, negative temperature coefficient of resistance, that is thermistor. Resistance decreases with rise in temperature. The temperature varied by two methods. One is raising external temperature, that is sensor mode. Second is passage of current through the device, that is self-heating mode. Now comes the applications. Very low temperature thermometers, and it's also used in digital thermostats. Then comes the application of battery pack monitors and in rush protection devices. This is a characteristics of an NTC. That is a graph showing the temperature and resistance. PTC, that is next is PTC, positive temperature coefficient of resistance, that is thermistor. Now Celestor, that is linear characteristic, and switching PTC thermistor, that is non-linear characteristic. Self-heating mode and sensor mode is available. Now the applications are current limiting devices and temperature compensation devices. Now again, this shows a characteristic of PTC. And these are some of the available forms that is available to us. And this is a form of forms and simples again. Washer and rod, high power applications. Now comes the variable resistor. Resistor is an electronic component with electrical resistance that varies with the applied voltage. And the voltage dependent resistor VDR is also available. The most common type of varistor is a metal oxide varistor. This contains ceramic mass of zinc oxide grains and a matrix of other metal oxides such as small amounts of bismuth, cobalt, manganese sandwiched between two metal plates, the electrodes. Now the applications: used to protect circuit from high voltage fluctuations by changing resistance, and handles to 1000 ampere current, voltage from 12 volt to 660 volt, temperature from -40 degrees centigrade to 85 degrees centigrade. Thank you.